Okay, this is from the SAT exam number 1 from College Board, and I'm going to go over the module 2 of math on number 25. A model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrel. Okay, so I'm gonna just pay attention to this phrase because we're gonna get the equation out of this. Okay, so okay, from previous year. So this year population is 150% more than the number of squirrel last year. Okay, we can use a variable, but we'll get there first. They want to tell us what variable we must use. Let's continue with the next sentence. The model estimates that at the end of 2016 there were 180 squirrels. So we can think that the table T versus number of squirrels, that we have 180 at the end of 2016. Now here's the tricky part. They said from 2015 to 2020, the end of each year. So we have 2015. So these are all end of 2015, and it's at 2016 that we get 180. Which of the following equation represents this model, where n is an estimated number of squirrels in the population? So I can just replace the right column or second column with n, the number of squirrels in the population T years after the end of 2015, and T is less than or equal to 5. Alright, so I'm gonna also replace this because at 2015 is a starting, the end of 2015 starting, so let's replace that with 0. End of 2016 is the first, or at least 1 year elapsed. Okay, and then we got 2, 3, 4, 5. Okay, so we have a table, and if you look at all the answer choices, we have an exponential function. So we have n equals, and for the exponential function, we have the original population, and then b to the power of x. But instead of x, we're gonna get t because that's our independent variable, and we need to find b here. So the key for finding this exponential base is to interpret the 150% more than the number of squirrel last year. So every year you're gonna get 150% more. Now here's the tricky part. The moment most people see 150% more, then people might think, oh, I just gotta multiply, or I just gotta replace b with 1.5. Now that's wrong. Let's rewind. So if I say 100% more, it doesn't mean that it's the same as the original. The fact that you just mentioned more means it has to increase. Therefore, if 100%, if you know that 50% more means 1.5 times the 1.5 from the previous population, 150% more actually means times 2.5. So if you had 100 people or 100 squirrel, the next year 150% more means 250, not 150. Okay, so we're gonna have to put the b as 2.5, and t is the variable from 2015 end, or end of 2015. Now we do not know exactly a here, the original population. This is n when t equals 0, but we have n equals 1. Okay, so we will do something about it. Okay, So they gave us this. When t equals 1, the n equals 180. So a here is the initial population. Or I could just replace this was as n naught. It's like the initial population. So you guys know that SAT allows you to use calculator. And if I divide both sides by 2.5, 180 divided by 2.5 gives us 72. So n naught equals 72, and that's going to replace where n naught is. So your ultimate equation should look n equals 72, 2.5 to power of t. Therefore, the answer is B.